Welcome everybody. In this video, I will show you how to use Minitab to compute a correlation and to conduct a simple linear regression analysis. For these, we are going to make use of the data shown in Minitab. We have talked about this data in the previous video. So in C1, we have years of service in Midwestern, and here we have the sales, and we have this 12 records. And here is a different type of data where we're looking at the relationship between length and weight, for example. So let's start with the length and weight. So length is our X variable. Remember, we said the X variable is the independent variable and the Y variable is the dependent variable. But for this, let's not think about independence or dependence. What we want to look here is we want to look at the relationship between length and weight. So it doesn't really matter if I made length X or weight X in this case. I just simply want to explore the data and see if there's a linear relationship between the two variables. Otherwise, I can start thinking about, okay, what do I want to predict? What should be my predictor variable? But let's just take, for example, I made length my predictor variable. So the first thing we want to do is create a scatter plot. How do we create a scatter plot? So to create a scatter plot, you have this menu called graph. So click on graph and you have scatter plot. And let's choose simple and click OK. And so for the Y variable, let's choose weight, double click. For the X variable, double click on length. And leave every other setting as default and click OK. And this gives you the scatter plot. So that's the scatter plot. What if I want to create a scatter plot with a line fitted on it? To do that, again, we go to graph, scatter plot. This time around, I would select with regression. So that would fit a line on my data points. And click OK. Y variable, select weight. X variable, select length. Leave everything as default and click OK. And as we can see from this, it shows that there is a linear relationship between the two variables. So there is a linear relationship, meaning that one of the assumptions for simple linear regression has been met. And next, how do we compute the correlation value between length and weight? How do we determine the correlation coefficients? Now, to do that, you go to Start this time around, Basic Statistics, and all the way down there, you have Correlation. So click on Correlation, and basically we use correlation to determine the correlation between two quantitative variables. I'll repeat what I said. Click on Start, go to Basic Statistics, Correlation. And it shows that it's used to measure the strength and direction of the linear relationship between two variables, between two quantitative variables. So what are our variables? Now, it doesn't matter, the order does not matter. I'll select X first and select Y next. So these are the two variables in which I want to compute the the correlation coefficient of. Remember, the correlation coefficient is a small r. So leave everything else as default. But if you just want to play around with these options, click on it to see what it does. So here, you can see the confidence level is set as 95 because that's what we generally set it as. Now, if in the question I said you should use a different confidence level, then here is where you change the confidence level in the options. For the method, leave it as Pearson correlation, and then click OK. And if you see it says store correlation matrix, leave that option, but you can play around with it and see what it gives you. And then you have the graphs. So we want to have a matrix plot, and we want to have a correlations and intervals, and feel free to play around with the different options as well. And then click OK. So with this, we have, you can see here in the result, it has correlations, and it gives us that the correlation between these two variables is 0.965. That's a very strong correlation. So the strength of the correlation is measured here as 0.965. So we can say we have a positively strong linear relationship between weight and length. Awesome, right? Cool. And you can see R is shown here in this visual, and this is the confidence level. So our R is this, and this is the confidence interval. So the true population correlation is between this and this. Remember that confidence interval we learned in chapter 8? Great. Now, if the form of this data was not linear, remember, if it's curvilinear, then the correlation coefficient R will be 0 or very close to 0. Now, if there is no form, like we saw in the previous video, then it's also going to be 0. If there are outliers, you will clearly be able to see if there are outliers from the scatter plot. And of course, you can make the decision of, do you want to eliminate the outliers, or investigate how this outlier was introduced, so that you can compute the right correlation. Okay, remember the correlation is always between -1 to +1. Okay, so in your homework assignments, you would have different graphs, for example, and you're to compute the correlation of whatever data that is given to you, create a scatter plot, and give your interpretation of the correlation. So is it a perfect negative linear correlation? By that, is it -1? Is it a perfect positive linear correlation, and so on? So that's part of what you would see in your homework this week. And what else? Now that we understand correlation and we know how to determine a scatter plot, let's look at a different example. Let's explore years of service and sales and create conduct a simple linear regression analysis of these two variables. Well, the first thing we can do is create a scatter plot of the two to see if there is a linear relationship between years of Midwest and sales. So to do that, you click on Graph, Scatter Plot. Let's leave it as simple, and let's add it with regression, and then click OK. And now we're going to change this. Now for these, we want our sales to be our dependent variable, so that will be the Y variable. So in here, sales will be what you're going to change for Y, and then X is the predictor variable, and that will be so Y variable is our sales, repeat it, and the X variable is the years of service. So that's the predictor variables, years of service. And if you leave everything here as default, just want to show you labels. You can explore, you want to put a title, subtitle, and so on, and click OK. And here you have it. You can see that there is a linear relationship. It's not curvilinear. There is a linear relationship. We can fit a football around this data. So it's a football shape. So if it's a football shape, that's good. I'm sure some of you love soccer. All right, great. And how do we compute the correlation R? You can do that again, remember, stats, basic statistics, correlation, and select years of service and sales. The order does not matter. And this will compute for us the correlation of 0.833. However, next I'm going to show you how to conduct a regression analysis using Minitab, so that you can get those outputs that I showed you earlier. So to do that, we are not going to create a scatter plot. So for example, I've shown you a scatter plot with regression and so on. But this time around, we'll go to Start, Regression, and Fit Regression. Okay. Now, when you do that, you now have these outputs, and in here it says responses, continuous predictors, categorical. We have no categorical predictor variable. We only have a quantitative predictor variable, which is our years of service. Our response variable is our sales. Okay, and you click OK. So when you do that, we have just conducted our first regression analysis. Yay! And here are the outputs that you'll get. So how do we interpret all of this? So you remember from the video, before conducting any regression analysis, we want to check the different assumptions. And we've talked about the different assumptions that we want to check. And also our goal is to have the equation that minimizes the sum of squared residuals. And so definitely this is the best result. But before we do this, I want to have the one that I'll show you another output. If we go and start regression, fitted line plot, I just want to plot to this first. Years of service is sales is our Y, years of service is our X, and regression type linear. And let's look at the graphs. So we can here select the different graphs we want. So individual plots, regular, so all 4-in-1. So let's select 4-in-1 and then click OK. And then you click OK. And right here, you also have the output as we've seen earlier. So this is our regression equation. Okay. And this is what we got in the previous video that I showed you. And this is the goodness of fit. Okay, 69.31, exactly as we got previously. And this is the sum of squared regression. So this shows that this model is significant because we have a p-value less than alpha, or the F statistic here is greater than the F critical value, which if you're taking my stat one, we've not discussed F yet. We'll talk about F when we look at ANOVA, analysis of variance. And so this is what I showed you in the slide. And so this is the fitted line plot. And we can see the R squared. And we can see that there's a linear relationship between years of service and sales. And here we can look at the different assumptions of normality, looking at the residual plots. And so we can see that the data is approximately normal. There might be some left tail outlier, something to the left, but it's approximately normal. So the normality assumption has been met. And yeah, so for this, for my Stat 1 class, this is basically what you really need to understand. And what else should I talk about? I think, again, I would repeat this whole step again. So we go on start, regression, fitted regression, or fitted line plots. And then you specify what you want. You can click on the graph to select the type of graphs you want. And then if you look at the options, if you want to transform any of your variables, so let's say you have a curvilinear relationship and you want to transform, say, the y variable to a log of y, to a log variable, so you can select any of those to transform them. If you want to change the confidence level, you can change it as well. If you want to specify a different title, you can do that as well. And you can decide to store the residuals. So let's say you want to now plot the residuals to yourself with the fits values. And so let's just store those two. And then click OK. So when we do that, it creates all for us here. You have the residuals and you have the fits. So now we can create a scatter plot of the residuals and the fits, just to visualize that. So residuals and fits. And when you look at it, you can see that there is no pattern. So the assumption of equal variance is met here. Okay. And basically, we also got this output in this diagram here. So this is the fitted value and the residual. So that's the output. So I've shown you how to create to create a regression analysis using Minitab, start, regression, fit regression as well. We can do that. And select the response variable and the continuous variable. Let's select graph. Let's choose the 4-in-1 graph. Click OK. And if you select stepwise method, what this does is finds the best line of best fits. This is beyond the scope of this video, so we won't deal with that for now, but you can play around with it yourself. But that's all we need for now. Let's press OK. And so we have our outputs. And looking at our output, how do we interpret this? This is the regression equation. This is our R squared. This is, if you come all the way down here, this is the t value. So for the slope. So if you're checking if the slope is significant or not significant, we can check here. So the p value here is clearly less than alpha of 0.05. And if you compare these with the t critical value, you can see that it's in the rejection region. So we're going to reject the null hypothesis, which means that the slope is a significant slope. And here we have the variance inflation factor. We are not talking about it in this class, but this is basically used to check for collinearity between variables. Having VIF of 1 is good, which means there's no collinearity. And we basically check that when we have more than one independent variable. So we want to check that all the variables are independent and not there's no multicollinearity in the model. Okay, and this is R squared. Talked about that already, which is the coefficients of determination. And of course, finally, we can decide to make our predictions using this equation. And generally, you should use values of years of service that's within the minimum and maximum years of service in the data that you use to create this model. So you can choose a different value, like say 5 or 7 or 9 or something within this range that is not in this years of service to predict what the sales would be using this equation. Okay, so if you made years of service, say 7, for example, and you multiply by 49.91, you will get something close to 349 or 350. And if you add it to this value, you have something around 525. So we can predict the sales to be about $555 or $525,000, given a years of service of 7, for example. All right, so that's a little bit about prediction analysis. And so with these, we have covered the Minitab aspect of the previous video. You now know how to compute the correlation coefficient. You know how to run a simple linear regression. You know how to interpret the basic outputs as shown in the previous video. And so with these, I wish you all a beautiful rest of the day or night or whatever time it is in the day. Have fun, stay well, and stay blessed. And one other mantra I love is spread love and kindness. Be good to yourself and have fun learning statistics. Bye for now.